So I'm not a teacher, I'm not a principal. What I get to do is I get to look at research and I get to scrutinise that research and try to work out what that tells us and how we can apply it in classrooms. So first of all, I'm going to go back in time and I'm going to start with a report that was written 50 years ago this year, and that's the Coleman Report. And so while educational research has quite a long tradition, a key moment in history was the Coleman Report. And it was done in the United States. And Coleman was a sociologist and he was specialising in education at the University of Chicago. And he was a pioneer of the idea of social capital. So in 1964, the US Office of Education gave Coleman the job of leading a team of 7 researchers to investigate the drivers of educational quality. They produced a report that was so extensive that a team of researchers they got together every week for a year and they still didn't come to the bottom of it. They still didn't work out exactly what they could find from that data. I'm not going to go into a great lot of detail about the specific findings of the Coleman Report because although they were groundbreaking in their time, they were 50 years ago and have since been contested and refuted. The biggest impact of the Coleman Report was that it changed the way that we think about education and how we look at the work of schools. And Eric Hanushek describes the Coleman Report as the fountainhead for those committed to evidence-based education policy. Hanushek, who is now at Stanford, was a graduate student at the time and was on that committee that scrutinised it. And Hanushek said that before Coleman, a good school was defined by its inputs: the expenditure, the school size, the curriculum, the volumes per student, the books per student in the library, their facilities, all those kinds of things. But after Coleman, the measures of a good school shifted to outputs, so how well the schools were doing in terms of gains in students' learning. So 50 years after Coleman, we're still grappling with the evidence that some teachers are more effective than others. However, these days the difficult task isn't accepting that teachers differ in their effectiveness, it's working out why that's the case and what we can do about it. So in recent years, the focus on teacher quality, or perhaps more accurately teaching quality, has been almost relentless. Numerous longitudinal studies have shown large differences in learning achieved by students with different teachers. So this slide, hopefully, shows some of those studies that have been conducted between about 2004 and 2010. So the measure of effect on this slide is the standard deviation. So standard deviation is a measure of achievement that's relative to the mean. The median effect in this group of studies is 0.15 of a standard deviation. Another study that was done in 2010 in Australia, so those studies in that graph are from the US. An Australian study found a similar effect. So students with more effective teachers, by which I mean teachers who are at about the 75th percentile of effectiveness, had test scores 0.15 of a standard deviation higher than students who had less effective teachers. So that's the equivalent of about a quarter of a year of learning. Now, you might think that a quarter of a year doesn't sound like a big deal, but the problem is that it's cumulative. So this study shows this slide shows one study's finding of the impact of having an effective versus an ineffective teacher over multiple years. So in this case, from age 8 through to age 11. In this study, the ineffective teacher is in the lowest 20% and the effective teacher is in the highest 20%. So after 3 years with the most effective teacher, students who started at the 50th percentile at age 8 moved up 52 percentile points higher, so up to the 90th. And students who were with a less effective teacher for 3 years moved down to the 37th percentile. So that can show the profound effect that having an ineffective teacher or a less effective teacher over a number of years can have on where a student is placed with respect to their peers. And other studies have found similar effects to that. Those numbers there are for maths, and you get similar effects for reading. So the question then is why? What is it about the teachers that's making the difference? So we'll go back in time again to 1967 with Project Follow Through. So Project Follow Through was published just after the Coleman Report, and again, a really groundbreaking study. And it looked at the outcomes of 75,000 students in 180 communities over 10 years, and it cost around $1 billion. So Follow Through obviously was an enormous experiment, and it involved comparisons of more than 20 different competing organisations, and they covered a broad range of educational philosophies and approaches, including things like child-directed learning, individualised instruction, learning styles, self-esteem development, parent-based teaching, direct instruction, and behavioural teaching. So all of those things sound very similar to the sorts of different approaches that we see today. Each of the sponsors had to have rigorous requirements for their program delivery. And as you can see from this slide, so on the far right of the graph, those columns there, that's direct instruction, capital D, capital I, direct instruction. So far and away, the most effective of all of those programs. So we knew that 50 years ago. And in follow-up studies, so both immediately and 10 years later, following up those students, they had the most consistent long-term benefits in reading, in all academic areas, but also in things like self-esteem. So that was an unexpected finding, that there would be the socio-emotional responses as well from DI. So DI, as in capital D, capital I, has been scrutinised and studied ad nauseum just about. A meta-analysis published in 2003 looked at 29 programs and models that had been implemented across whole schools to improve their performance. There were 49 studies of DI that met the research quality criteria and were included. The average number of studies for the other programs was 4. And this was just those whole school reform movements that had used DI. It doesn't include the numerous studies of individual DI programs or subgroups of students. So before I go any further, I should explain what I mean by DI. So the terms direct instruction and explicit instruction tend to get used interchangeably. So when we're talking about direct instruction and explicit instruction in lowercase, we're talking about a general set of instructional principles. We're not talking about a specific program with lessons that are delivered as they're produced and published. There's sorts of techniques that can be used in any classroom, in any discipline, and not just in classroom. The DI principles are used in sport coaching, for example. So it's really just some approaches and a set of characteristics of teaching. Direct instruction with capital D, capital I is a specific program that is a published program that teachers can deliver, hopefully the way that it was intended to be delivered, and it's scripted, and it also includes curriculum. So that's another major difference between little di and big DI, is that big DI includes the curriculum content as well. Explicit direct instruction, also spelt in capital letters, is also a specific program that includes curriculum content and pedagogy. And again, that's a set of published programs that are a specific set of lessons that schools can purchase and put into place. So I'll try to remember to talk about big DI or little DI as I go through the rest of the presentation, and I hope that you'll know what I mean by that, that big DI is the specific published program, little DI is a general set of instructional practices. So what's little DI? It has a set of characteristics which are generally credited to Barak Rosenshine, and he came up with this, which is probably the most concise list of characteristics. So that you can read through those. I'm not going to read them out. I'll just explain. The essence is that the classroom is very teacher-directed. Children face the front of the room. There's a higher level of interaction between the teacher and the students rather than between the students and each other. Students are told exactly what they're going to be learning and how they're going to learn it. They are provided with new information in a very sequenced and systematic way, in a way that builds knowledge in a logical progression. Students are frequently monitored in the classroom and through their assessments to make sure that they understand what they're learning and that they've mastered the material before they move on to the next sequence or the next information. And there are also follow-up assessments to make sure that that information is retained. So it's not a matter of teach and test and then forget. To many of us, that sounds like common sense, but it's also supported by theories and findings in cognitive science, as well as the applied research that I just mentioned. In recent years, there's been an attempt to identify and quantify these specific aspects of teaching practice in schools and classrooms to see the impact that they have on students and to compare them. So the intent of that exercise is so that teachers and principals and school systems can put the most emphasis on the practices at work. So John Hattie's research synthesis, published in 2009, called Visible Learning, looked at the research evidence for thousands of studies for dozens of different variables. And since most variables seem to have some sort of positive relationship with learning outcomes, the question is which ones have the most impact. And in perhaps the least surprising news ever, it found that the sorts of teaching practices generally associated with explicit instruction or direct instruction have a larger positive effect, and in many cases a much larger positive effect than the sorts of practices associated with inquiry-based or discovery learning, which is the sort of approach that is based on the idea that children construct their own knowledge. If you give them a project or a theme or an outcome, that they can construct that themselves through group work with very little guidance. A team of cognitive scientists who have been very interested in the way that people learn, Kersner, Sweller and Clark, put it this way. They said, insofar as there is any evidence from controlled studies, by which they mean experimental research, it almost uniformly supports direct, strong instructional guidance rather than constructivist-based minimal guidance during instruction of novice to intermediate learners. Even for students with considerable prior knowledge, strong guidance while learning is most often found to be equally effective as unguided approaches. Not only is unguided instruction, so discovery-based or inquiry-based learning, normally less effective, there's also evidence that it may have negative results when students acquire misconceptions or incomplete or disorganised knowledge. So I'll just mention a few more recent studies. One of the criticisms often of both big DI and little DI is that it's about rote learning of facts, that it's about drill and kill, and it's just useful for fundamental sort of basic skills. And there's more and more research accumulating to show that that's not true. There's a series of studies which look at development of what's called metacognitive strategies. So things like understanding of concepts and then transferring them from their initial concept through to other sort of more authentic circumstances or more authentic scenarios. And this particular study was of grade 3 students. And I think I've gone too far. Yeah, so this is the first one. In that group of studies, and it showed, as you can see there, that the students in the discovery learning group were much less likely to master those metacognitive strategies. And the strategy that they were looking at was the control of variables idea, which means that, which is the idea behind experimental studies, that if you're trying to work out what, or try to develop an idea of cause and effect, that you need to control some variables so that the differences between the two groups can be isolated. So that's a fairly complex idea for young students to grapple with, but with some initial or direct instruction, children are more likely to retain that information and to transfer it into new contexts. In the next set of studies, they tried to work out whether or not when the direct instruction occurred made an impact on how well students learned a concept, whether if they were given direct instruction first or a high level of guidance, so the H there stands for high and the L stands for low, if they had high level of guidance both at the beginning and towards the end, whether or not that might make a difference compared to other scenarios where there was a combination of high and low guidance. And again, you see that the high level of guidance, so initial explicit instruction, had a bigger impact on the number of students who achieved mastery in that concept. And that was both immediately and then 24 weeks later. So there was a retention of that information. And again, another study looking at a similar thing, but this time separating the students into groups of low achievers and high achievers. The red line at the bottom there is students who were initially in the low achieving group who were not given explicit instruction. They remained low. The children who were initially in the low achieving group are the blue dashed line. After explicit instruction, they were up near the high achievers. So their growth was phenomenal. So you can see there that these groups of studies show that direct instruction is not just about rote learning. It's not just about facts and foundation sort of principles, but also it can apply into these sort of more complex things, and also with varying groups of students. And this was a study that a lot of people found very surprising, was that direct instruction actually improved creativity. And again, you can see from the numbers here that the students who had some direct instruction in how to creatively generate ideas versus those students who just sat and brainstormed, more like a discovery learning approach, had generated more original ideas. And so, again, it shows that there's a wide application for these teaching techniques. And, of course, for reading. And reading is probably the area where direct instruction has the greatest amount of evidence. And the clearest evidence there is particularly for phonics instruction, but it applies for all of the different components of reading instruction. So this is a very well-known study called the Clackmannanshire study, and that was in Scotland. And again, it shows that that students who were in a synthetic phonics group, after 16 weeks, they were already 7 months ahead in terms of their reading than their peers who didn't get that systemic and synthetic phonics instruction. So this is a really interesting study because the progress of that first group of students with the explicit instruction in phonics was so strong that instead of continuing the longitudinal controlled study, it was felt that it would be unfair on the other students not to offer them the same instruction. So the researchers decided that they would sacrifice their controlled study in these circumstances and give all children access to that type of teaching, and then compare them with their expected reading age. And in this study, you can see their expected reading age continued to, or their real reading age or their measured reading age continued to be higher than their expected reading age right through to 7 years later. So not only are these applied studies that show how these sorts of techniques work in the classroom and how effective there are now a number of other disciplines that are providing information and evidence, and also some theories about why this might be the case. So with explicit and direct instruction, there's a coalescing of research and evidence from various different disciplines to support it. So this particular theory is called cognitive load theory, and it explains that our working memory is limited. So therefore, there's only so much information that you can hold in your working memory, and we need eventually to move information into our long-term memory. And so where that fits in terms of, say, reading instruction is that once you know how to decode, once it becomes automatic how to read the letters and put them into words, then you're not having to focus on that as you're reading. You can focus on comprehension and meaning. And that is a really neat and plausible, but also an explanation that's gradually being also supported through neuroscience. So what we now know about how the brain learns to read is supporting, again, explicit and direct instruction. So we now know that there is no reading centre in the brain. So it's not just a matter of exposing children to print and that part of the brain will leap into life and all of a sudden they'll know how to do it. That there are a complex set of connections that need to be made between different areas of the brain that had evolved initially to perform different functions. And for many students, those connections can only be made through explicit teaching and through repetition and through practice and all those sorts of things that we talk about when we talk about explicit and direct instruction. So that's what we're focusing on with the 5 from 5 project at CIS, is to take that evidence, particularly on reading and explicit teaching of reading, and try to make sure that as many people as possible have access to that and understand how it applies in the classroom. There's an overwhelming weight of evidence in terms of explicit instruction, particularly in reading, but it's not always finding its way into classrooms. So we're developing resources for parents, and that is now available on the 5 from 5 website, but we're also developing resources for teachers now to try to make that as easy as possible for them. So education's a high-stakes profession. Educators should have the same sort of professional and ethical responsibilities similar to that of doctors. So at least to do no harm. And in the case of education, the harm's not physical necessarily, but the harm that can come from not getting a good education, not being able to read. So all of us who have an influence on children's education, either directly, like teachers and school administrators, or indirectly, like myself, have a responsibility to make sure that what we're doing is the most likely to have the best outcomes. It's not enough just to think we know what works best, or to do what seems like it might be working, what children are enjoying. We have to minimise as far as possible the risk that we might be wrong. And the best way to do that is through the application of the findings of the highest quality research, specifically that uses scientific evidence protocols. And that research overwhelmingly points towards direct and explicit instruction. Thank you.